Alright guys, how's it going? This is 2.2, Patterns and Linear Functions. So what we want to be able to do here is recognize patterns, graph them, determine if it's linear, all that sort of stuff. So here, this is something that I was actually just doing last week, looking at patterns of shapes and the amount of size it takes up. So in the diagram, what's the relationship between the number of rectangles and the perimeter of the figure that they form? And this is important, especially when you do like hardscaping for landscaping, like when you put in patios. So you need to know how much edge there's going to be because you have to put down an edge around the whole thing. So if we have one rectangle, it's a 1 by 6. So think about the perimeter there. Think about the 2 by 6 rectangle, the 3 by 6. Go ahead and write the perimeters down here below them. So pause the video, take a second. Alright, so here I've listed out my perimeters below. And so we're going to make a table. And we want x to be our independent variable, and y is always our dependent variable. Y depends on x. So if x is independent, the things that are independent is the number of rectangles. The thing that is dependent is the perimeter. So x is independent and y is dependent. So then we can fill out our table here. We have one rectangle, or 2, or 3, or 4. So then we know our perimeter is 14 and 16 and 18 and 20. And then we want to list out all of the ordered pairs that go with that. Alright, so make sure you have all of your ordered pairs listed out there. So now as we head on down the page, so our pattern, if we want to describe it in words, would be that we add 2 for every brick, right? Because the perimeter is increasing by 2 every time we add a brick. So if I come over here to graph it, one brick had a perimeter of 14, which if I look at these gaps are 8, so this must be 12, so that'd be 14, 16, 18, and 20 to plot all those points. So what we see here is that we have a linear relationship. It's not proportional because it doesn't go through 0, 0, but it is in fact linear. Alright, so now we want to do kind of the same thing, but instead of with rectangles, we want to do it with triangles. So take a moment, pause the video, and fill out these tables for your independent and your dependent variables, remembering that x is always independent, y is always dependent, and fill in the values. Alright, so what we can see here is that our independent variable is going to be the number of triangles, and our dependent variable is going to be that perimeter around the triangles. So if I only have one triangle, I've got a perimeter on that one triangle of 10. But once I have two triangles, I now have a different shape, and my perimeter on there is 4 on top and bottom, which makes 8, 3 on both sides, which is 6, so that gives me a perimeter of 14. My 3 triangles then, I have 3 4s and still the 2 3s. So now I just go up by 4 again. And you should be starting to see a pattern that we can verify after this last one. If I look at that perimeter, it is in fact 22, which means that we are increasing by 4 every time. And what we could then say written out in the verbal is that we are increasing by our dependent variables increasing by 4 for every change by 1 of the independent variable. And then if we fill out the table vertically, it is the same. 1, 2, 3, 4 for my triangles, and 10, 14, 18, 22. And I went ahead and wrote the words up top there. So then if we graph this, let's use your table to make the graph. So we've got a very tall graph here because we are taller than we are with the x variable. So go ahead and plot your points. Now you can list these points, but they're already pretty much listed right here, so go ahead and try that. So then I find it best to label my graph the y-axis by 2s so that we can actually fit on this graph. So I shrunk my graph down a little bit so that you guys could see it on here. But so at the point of x being 1, where does my y go? Yeah, at 10. Then when x is 2, we have y at 14. And when x is 3, we have y at 18, and when x is 4, we have y at 22. And we can go back and label our x and y axes if we want of triangles and perimeter. And again, because the tablet that I'm using, it does not look great, but here we go. A nice final graph, number of triangles and perimeter both labeled on the x and the y axes. Alright, so now we have a problem here about a digital camera. So the table on the right here shows the amount of memory left in a camera or on the memory card as you take pictures. So notice that when we start, the number of photos on it is empty, and actually the memory that we have here, the 512, that is half of a gigabyte. A gigabyte is 1024 megabytes. So we have a half gigabyte empty. Is the relationship a linear function? Well, to check if it's a linear function, we want, as the x changes consistently, so here my x is increasing by 1 every time, we would want our y to increase or decrease by something consistent as well. So you go ahead and make this determination, is this a linear function? And in fact, each of these changes is losing 3 megabytes, so that is a constant y change as we have a constant x change. So yes, this is a linear function. So then we know, as we come down here, the memory is blank before any photos are taken. Well, how much is in the memory? There is 512 megabytes if you care to label. And then the independent variable, always our x-axis, is the number of photos that we take, and the dependent variable is the memory. The memory depends on how many photos. So we label then that as the independent variable x increases by 1, the dependent variable y decreases by 3. And go ahead and plot the points as far as we can on this graph. Pause the video and take a second to do that. And for everything that we know, the table that we had, that is the full graph for what we can fit, up to 4 photos, and now we're down to 500 megabytes because of that relationship. So how can we tell if something is a function? This is a big question that they get to on the PARC test. So a relationship is a function when each input has exactly one output. Now, an output can be used more than once, but an input cannot be used more than once. So let's check that out down here. And if we graph this, again, I often find it easier to scale my y-axis to make it fit with whatever situation we are in. So we have a y-axis scaling of 2. So 0 starts at 8, so I'll go ahead and start that point at 0, 8 right there. And then 1 goes up to 10. 2 goes up to 12, 3 matches 14. And when we ask, is it a function, we can check with the vertical line test. So at anywhere on the graph, I should be able to draw a vertical line and not intersect more than one point. So if we move that vertical line left or right anywhere on this graph, we again can only hit one point at a time, which makes this check out that it is a function. Alright, that is all that I have for you guys on patterns and linear functions. So please download the homework, make sure you work on that until you understand it, and please let me know if you have any issues. Have a wonderful day.